Hi everybody. Today our video notes are on verifying inverses. In other words, determining whether or not two graphs are inverses or two equations are inverses. So let's take a look. The first method is by using a graph. So if you have a graph of two functions or two relations, are they inverses of each other? Notice this dashed line. That's our line of symmetry. Remember that that line is y equals x. Then if you fold over this line, you should land on the other graph. Okay? So sometimes though looks can be deceiving. So to make sure, if we look at this point here is at -1, 1. Now, remember we switched the x and the y, so if we switch the x and the y, we get 1, -1. So if we do 1, -1, it lands right on top of that point. So these 2 points are definitely inverses of each other. Okay, let's check this point. So this one's going to be 0, 1, 2, 3, 4, 5. So 0, 5. So if I switch the x and the y, we get 5, 0. 1, 2, 3, 4, 5, 0. Okay, so it looks like they're all going to work. But let's just do the one on the end. We get 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. So this one's 7, 8. So the inverse point would be 8, 7. So let's try it. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. So those are definitely inverses of each other. The second way to determine if two functions are inverses are by graphing them. So let's take a look at these two equations. Okay, so let's go ahead and graph them. So our y-intercept is 2. So 1, 2. Our slope is 1/3. So rise 1, run 3. Rise 1, run 3. Rise 1, run 3. And same thing in the other direction, except the opposite. Okay. Alright, so our y-intercept is -2. Slope is 3/1, so rise 3, run 1. Rise 3, run 1. Rise 3, run 1. And the other direction. Down 3, left 1. Okay. So now I'm going to go ahead and put in y equals x. Let me get my ruler out. Alright, drawing y equals x. Y equals x goes through the origin. Up 1/1, up 1/1, up 1/1, up 1/1. And here is y equals x. Do they look like that's the line of symmetry for those two lines? They do not. They do not. And if you notice, this point here is 0, 2. The inverse would be 2, 0, which would be right here. And the other line does not go through that point. So these are not inverses. No. No. Okay, let's turn the page. It says if functions f and g are inverses of each other, then f of g of x equals x, and g of f of x equals x. Okay, so simply put, we're going to take this function here and plug it in to the other function for x. That would be plugging g of x into f of x. That looks like this. That's plugging g of x into f of x. So we would have 2. Okay, then for x, we're going to plug in g of x. Okay, plus 4. We're substituting this function into the other function everywhere we see an x. Now, next thing we want to do is we want to simplify this. Now the goal is for our answer to be x. Let's find out. 2 times a half, it's going to be 1x. Distributing, 2 times negative 2 is negative 4. Negative 4 plus 4 is 0. So, did we get x when we plug g of x into f of x? Yes. Okay, now we got to do it the other way. So now we're going to take f of x and we're going to plug it into g of x. It's going to go something like this, g of f of x. Plugging f of x, that's this function, plugging it into function g everywhere we see an x. Okay, so we're going to start with g. So 1/2. Okay, x is going to be 2x plus 4. And then the rest of the function is minus 2. Now what do we want the outcome to be? We want the outcome to be x. Alright, so distributing, that's going to give us 1x. Multiply again, that's going to give us 2. And we get x. Now if it goes both ways, you get x for both of these, then it is a function. Yes, it is. They are inverses of each other. Yes. Okay, it says determine both algebraically, that's this method, and graphically, that's this method, whether or not f and g are inverse functions. Okay, so let's do that. Let's start off by graphing. Okay, we're going to have 3, so 1, 2, 3. Slope is 4 over 1. So I'm going to go ahead and pause the video and come back to you in a moment. Okay, so I plotted both equations. So this one is here. This one's f of x. This one is here. This one's g of x. And then I did the line of symmetry. Okay, so if I fold this over the line of symmetry, will it land on itself? No. And we can also check the points as well. This point here is 0, 1, 2, 3, 0, 3. So the inverse should land on 3, 0. 1, 2, 3. And it doesn't. So they are not inverses of each other. They are not inverses of each other. Okay, now let's use algebra. Now let's do f of g of x first. Okay, so we're going to plug function g into function f. Okay, so start with function f. 4, and then plug function g in, finish up function f. Okay, 4 times 1/4 x is 1x. 4 times -3 is -12 plus 3. So we get x minus 9. And that's does not equal x. So not inverses. Not inverses. Okay, let's take a look at the next one. Let's go ahead and do the algebraic method first. We'll do f of g of x. Again, function g goes into function f. So we're going to start with function f, which is 3x plus 6, so 3. Okay, function g goes in for x, so 1/3 x minus 2 plus 6. Multiply, and then we get 1x minus 6 plus 6. And we get equals x. Check. Okay, now we're going to do it the other way. So g of f of x. So we're starting with g. So we're going to have 1/3. Okay, in for x is going to be function f, which is 3x plus 6. Okay, finishing out the function is minus 2. So distributing, we get x plus 2 minus 2, and we get x. Double check. So yes, they are inverses. So you do the graph both of these lines, and show me the y equals x, the line of symmetry, and they should be inverses of each other. All right, see you tomorrow.